Welcome to another 3D printer review video. This is FLSUN S1 Pro, fast Delta printer. And this video is not sponsored by FLSUN, we don't have any kind of the contract and I'm not paid to do this video. However, this video is sponsored by Polymaker, who became a channel sponsor too. Now back to this printer. This is the fastest consumer 3D printer currently on the market. The maximum speed is 1200 mm per second, acceleration 40,000 mm per square seconds, and peak flow 110 cubic millimeters per second. These are insane numbers. Just for comparison shortly, I place next to it numbers for Bambolab X1 Carbon. The build volume is 320 mm in diameter and 430 mm in height, but it is not completely cylindrical. On the top we have some kind of cone. This is because of that delta mechanism. They cannot reach each part of that cylinder. The maximum noise is 55 decibels. This is important information because the previous S1 and T1, they were very loud, and this should be quieter. And 55 decibels, I will measure this, but this sounds acceptable. This is not new printer on the market, and I will concentrate more on the print quality, accuracy and similar, not on the hardware itself. For example, I want to measure the accuracy because I read somewhere that we have different accuracy with Delta printers if you print in the center of the build plate or somewhere near the edge. Then I want to see that bed leveling accuracy, maximal flow and similar. Of course, I will print some different materials from PLA, then I will print PPS because it requires high temperatures above 300 degrees Celsius, and also I will print some PCABS which requires actively heated chamber. I really like Delta printers, and on my workplace I have a Super Racer and V400, and anytime I'm presenting printers to my students or we have some exhibition, the Delta printers are always the most popular because of that hypnotic movement of those arms. Now unfortunately Super Racer recently died, not sure stepper motor or mainboard, and I cannot buy the spare parts anymore from the FLSUN. Let's get back to the S1 Pro. The packaging is good, only I don't like this white styrofoam. And this is very heavy printer, so definitely those instructions for unboxing are useful. This is very heavy printer and we have separate instructions for the unboxing. Additionally, this was inside the printer. Some tools and spare parts, user manual, power cable. These are the doors. Half kilogram spool, which is really nice because I hate those sample filaments few meters. And then we have this screen, two USB plugs and the power switch. On the back side we have some plugs too, and they are numbered. We have two doors, one is for the bottom part and the other will cover this place where the spool goes. I noticed a small issue, this magnet is not glued, and when I open the door I can hear it. Texture PI sheet. It's one-sided. And those limiters on the back side could be a little bit bigger. Okay. Removing the clips from the belts, and we have three. And now connecting the screen. These cables are labeled. And only two USB plugs will be used, number 2 and 3. There is no number 1. It's a little bit confusing in user manual. It says connect the power cable and 3 data cables. Connecting the power cable and the hardware installation is finished. Let's turn it on. I thought the glass is too dark, but with these LED lights inside it is very visible. Let's try homing. I'm not sure if you can hear it, there is this annoying noise. I believe that they are coming from these stepper motors. But if I turn them off, it completely disappears. It's connected to the network and it offered a firmware update. Also I could connect over my phone using that IP address. Oh, now it offered another update, okay. The update is finished and it asked me to calibrate the bed and do the input shaping. Let's start with bed leveling. And for this it will need approximately 5 minutes. Vibration compensation, that's input shaping. And for this it will need approximately 3 minutes. And now I can insert the filament and it's ready for printing. Not really the most comfortable method. There is no space for my fingers when the spool is inside. Maybe inserting the filament first and only then place it on the holder. From these prepared G-codes, two things I want to print, the Benchy and the silencer. It starts with the purge line. Oh boy, this is really speed. Later I will measure the noise when I will print the silencer too, but with open doors this is quite loud, but most of the noise is coming out from the cooling air. This is real-time speed. I can actually see this Benchy, how it starts to exist in front of my eyes. That was the critical bridging. This was 8 minutes together with the heating. Bet that you can check until it's hot. It's good. Bed is 45, let's try to remove it now. Perfect. I know what color is not the best for the camera, but with my bare eyes I can see that this is a nice Benchy. 8-minute Benchy with the heating time. Next is the silencer, and then I will prepare the slicer and my own G-code. This will be approximately 1 hour printing, but it would be good to see a remaining time too. The bed completely cooled down and it always pulls that last string. I'm not sure why the manufacturers don't add that small retraction at the end of the printing. Now let's see. Oh, perfect. Interesting, there is something in it, but I'm not sure how. Can you hear it? It goes here because this extruder don't have a part cooling fan. It sucks the air here and through the pipe it blows the air, and with this we have much stronger part cooling, and with this we can reduce the noise a little bit. Here is another space for improvement. Maybe you can hear the noise of the stepper motors which tries to hold the position. And now if I switch it off, you can still hear this buzzing sound. So the correct method is to unlock the motors. It's quiet now. And it will stay quiet. Next, printing Polymaker Scientist, and look at this printing time on Bambolab A1, 1 hour and 20 minutes approximately, and on S1 Pro a little bit more than 20 minutes. This is 4 times faster. And if I enter the IP address, I can start the printing directly from the Orca slicer. Upload and print. And this is what I can see from my laptop. The start is good, and later I will check the bed leveling, and now it will speed it up. Oh yes. Wow, looks like this will be really printed in 20 minutes. I can see some stringing. That last string. So yes, this was printed incredibly fast, and the only problem with this figure is this stringing, mostly here below the arm. Now, next few tests you will see are just to satisfy my curiosity. For example, I want to see how much weaker will be the layer adhesion, if it will be weaker, if we print on this higher speed compared to the speed on Bambolab A1, for example. Test objects are printed with 2 walls and 20% jarred in fill, and this cat is here just to keep that fast printing. It starts with the printing so fast that when I upload the printing from my working room and I work here, it already starts with the printing. And this is now the second layer, much faster. And this is that speed on that smallest cross-section area. It finished it very quickly. Can you hear that? Very often I can hear this sound when the nozzle drag over the top surface of the printing. Test objects are almost finished. The cat is here just to keep this high speed. The total printing time was approximately half hours. Few strings, but nothing special. These are marked and I will reprint same test objects on Benchy A1 using the same filament. Printing time was 3.5 times slower. Lejelet kezdjem with S1 Pro. And with A1. Weaker, interesting, maybe because S1 Pro printed on 230 degrees Celsius, A1 on 220, but these are all default settings. And now bed leveling test, and I want to clean this surface to avoid seeing my fingerprints on the printed object. The start of the printing was only 1 minute later since I uploaded the print over the network. The diameter is 300 mm here, and the start is okay so far. This is very promising, but I will repeat this printing later with the ABS filament. Now the bed temperature is 60 degrees Celsius only. With increased flow rate it would be connected completely, and it is very constant. And with second layer would completely cover it. But be careful, don't place the sheet on those back supports. Later I will check this with the ABS too. Should I test this with the 2 layers in the future? Let me know down in the comments. And after my V400 review video, I got some comments that these Delta printers have different accuracy depending on the position of the bed. Well, this is something definitely I want to check now. The printing is very fast, but what is really scary is the moving between the objects. So pay attention, never put your hands there. They are labeled center, left, right, up and down, and this is the X position. Now let's measure them. On purpose I don't have any printed symbols on these cubes, and in this video I will just show you the measuring of the center and the left cube in X direction. 19.850, 19.811. Each direction is measured, and later I will show you the numbers in Excel sheet. Let's analyze this now. Before analyzing, I want to repeat the same test with cylindrical objects too. I started the printing and I was finishing some email. In the meantime it finished 60% of the printing, and this traveling speed is extremely scary. Okay, let's measure these ones too. Now I realize not the best object for this kind of measuring. I have to be careful not to measure on the seams line, which is almost exactly on the y-axis in all 5 cases. But I mark it, and just 2 I want to measure in the video: the center in y direction 19.72, and on the left side, which was bigger in previous measuring, 20.13. And again each direction is measured, and this is speed up video. Interesting, I can see some peaks on the left side in y direction is the biggest, and on the right side in y direction is the smallest. Let's check this with some specific printing. With this printing I'm curious only about the accuracy in y direction, and this will be only 4 minutes printing. Okay, let's see that y direction. I am measuring above the elephant foot. This is the right side. 49.77. The design is 50 mm, and the left side, which should be bigger, and it is 50.2 mm. This is more than 0.4 mm difference between left and right side, and this can be even visible with the bare eyes. So if we analyze the dimensions on the graph, clearly we can see that on the left side in y direction it is bigger. Another conclusion: in z direction it is always bigger. This means the z offset could be lowered, and this can be visible in the later bed leveling test. Now there is one thing I don't really like in this design, and I'm talking about this heater block here. Even other YouTubers with S1 earlier noticed that here we have some kind of CHT channels to improve the flow rate. But the material of that block was from the aluminum, I think. And I asked the FLSUN, even until the printer was in the shipping, if they changed something here, use different materials or maybe change the design. And let me read their answer. The heater block is made of brass, plated with nickel, and the nozzle is made from bimetallic hardened steel. Long-term use of carbon fiber filaments may reduce the melting capacity, but it will not wear out the nozzle or affect the extrusion and forming process. This means by time those channels will wear out a little bit and we will have a smaller flow rate. Now with the carbon fiber filaments this is true, because definitely you don't want to print, I don't know, PPA, PPS, CF on higher flow rates, and for this the melting capacity even of the wearing out heater block is enough. But if you want to switch later to the PLA or regular ABS, in that case maybe you can notice some reduction in the quality because of that smaller flow rate by time. Now I want to test this, but I'm not sure how. I will try to measure the flow rate currently with this PLA which is inside. And after this I will try to print, I don't know, at least half or 1 kilogram with carbon fiber filaments. And I will try to measure that flow rate again. And if I will notice some significant change, it will be just a post on my YouTube channel, maybe in a month or two, I will see. So don't forget to subscribe or you will miss that information. But maybe a simple solution would be using two different hot ends, one for the carbon fiber filaments and the other is for the ABS, PLA and other high flow regular filaments. Time for the max flow test. 230 is the default temperature for this filament, and here you can see the maximal flow test will be from 50 up to 110 cubic millimeters per second, and here you can see this in slicer too.
I have the feeling that this will be very scary on the higher flow rates. This is just the beginning.
Well, even now I can see some degradation in the wall quality. I have to stop it earlier. Now let's analyze it. Okay, let's record this for my documentation. The wall is completely fine until here, 22 millimeters from here, and I calculated it. It is 75.9 cubic millimeters per second flow. And here it became almost transparent. This is on 30 millimeters, which is 85.3 cubic millimeters per second. Here we see what will happen after, I don't know, half kilogram carbon fiber filament. Some YouTubers claim that independent support layer height is causing some problems, and I want to check this.
In this first printing, those supports have a bigger layer height compared to the main object, and according to some of my YouTuber colleagues, there is a big chance that those supports will break off. But I'm using Orca slicer. Maybe in this slicer this is solved, we will see soon. Well, most of the supports is finished, so I don't have to reprint this object. Looks like this problem is solved. It was finished correctly. I can see that it could use here some supports on the ears too.
But otherwise it looks nice.
It is time to replace the filament, unload, and then we have these instructions. Not really the best method, at least, which I like.
I have to take out the Teflon tube, and then here I can cut the filament, and I have to extrude to the nozzle rest of the material. This means the filament goes only in one direction.
Switching to Sunloop PC ABS. I have a review in progress. Unfortunately, it is also in the white color. And what is specific for this filament that it requires 90 degrees Celsius heated chamber. Now the test I'm running on 65 degrees, and I will see if 50 is enough inside the S1 Pro.
Filament is loaded.
The heating up time was very fast, even to 105 degrees Celsius, and I am reprinting that bed leveling test because I want to see how it performs when the bed temperature is 105 degrees Celsius compared to 60 previously. It will be finished soon, and as expected, unfortunately, it's a little bit too low, especially on this left side. It is extremely low in the middle. I will clean it soon, but I'm not sure if you can see these waves. This is some kind of Moyer effect from this delta mechanics. It's completely cleaned without any damage, and it's ready for the next printing. Interesting, this time the first layer looks much better. I think I will stop the printing, definitely huge warping. 50 degrees Celsius is not enough. I mean, it requires actively heat the chamber. Well, to be honest, I was expecting this because it really requires 90 degrees Celsius actively heated chamber. I will try the same printing, but now with the regular ABS. Okay, green color. This is now ABS. The filament change is successful. It's hard to see through this glass clearly, but this first layer looks okay. Maybe it's just a little bit lower, but I don't want to open the door for this ABS printing. Well, definitely it looks much healthier now. I shouldn't even try the PC ABS with this printer, but I was curious. Nice. Let's see if I can remove it. Oh, perfect. And now I'll try printing with PPS CF10, and this filament requires print temperature between 310 and 350 degrees Celsius. Filament loaded, ready for printing. The start is good, and also have the review in progress with this filament too. This filament has a specific metallic sound, that's why I want to try to print the bell. And it's finished. Quick bed adhesion check. It's good. PPSCF. In the meantime, I started with the printing of these corner brackets for the alloy extrusion. I have to go to my workplace, so these brackets will be finished without my supervision. The bed completely cooled down. This is quite good. I need two hands. Alloy extrusion corner holders. Printing in vertical position is easier, but how much stronger is printed in horizontal position? Well, something I will test soon. With different materials. The filament is changed, and it's a little bit tricky because the previous I need to extrude on almost 300 degrees Celsius and the ABS on 250, for example. And the same bracket from the ABS printed horizontally and vertically. I will need a lot of these because I want to test with them a little bit more. What I like with ABS, when the bed cools down, I can even hear a pop sound, how it shrinks, and probably it is completely removed now. Let's see. Almost. Oh. Yes, definitely the Z offset should be a little bit higher with this temperature. Before we start, a quick opinion from my wife. It is a beautiful piece of hardware, we can keep it as a decoration if nothing else. Oh, it is super fast, but it is very loud, and never accept printer which is packed in a white styrofoam. A friend of mine asked me for advice. He wanted to buy a 3D printer for his kid, and he asked me what is a good but still quite slow printer. And I was confused, I didn't understand at that time, and he explained me he don't want to buy filaments too often. Well, definitely the S1 Pro is not good for him because this printer can eat more than a spool per day. So with this video I tried to answer my questions I had earlier. And is this printer ready for technical filaments? Well, according to specification, yes, but I wouldn't rely on this printer as the only one. I'm sure there are applications where it can perform great and it can print very fast, but if I really need some high accuracy, in that case I wouldn't rely on this printer. Maybe in that case the Core XY or Cartesian printers are better. I'm not sure is this the case with all Delta printers. If you have some experience with this, then please write me down a few lines in the comment section. And also I don't like that it is not really 100% ready for carbon fiber filaments. Well, of course it has great other advantages, but if you have some other experience, a few lines in the comment section. Thank you for watching and happy printing.